All right, ladies and gentlemen, let me once again put just the right amount of light on this situation. So, in this video, I wanted to cover a couple of things. A little more detail about how I'm expanding the capabilities of light. One, we need to start treating light as a charged particle and observing how it interacts with charged particles because it does travel as both a wave and a particle. That's true. But we haven't really looked at it in terms of its charge and what that really does to objects in the universe and how the sun is a giant electromagnetic ball that is charging objects that approach it. That's serious. That explains these objects' acceleration. But within that, there is one more thing that is really the expansion of how we see light. Traditionally, we see light as traveling in a couple of formats. And we know that we can have, say, a laser beam and focus light waves in real life, but we presume that doesn't come from the sun. But I suggest to you that off any light source, including the sun, I can generate these kinds of lighting effects like you're seeing right here on your screen. See that? How I'm putting my finger here and you can still see it? That is not on the surface of the phone, guys. And yet it is. This is a light effect that is focusing the beams of light in very pinpoint places. And we may very well see, imagine that an asteroid is here. Doo doo, doo doo, doo doo, and bam. Now it's interacting with that direct beam of light. And what do you see on the tip of my finger? A shadow. It could be that this object is in shadow, and yet the light is hitting it just right, generating heat. And this outgassing happens here. Well, you wonder why. Of course it does. The rest is in shadow, and only this is in that light. And as soon as it gets into that cone of light, you can see right away what happens here. Now, the deeper we get into that cone of light, the more pinpoint the light here gets, and the more direct and the brighter it gets. And the more we go back, the more that light spreads out and is duller. But even at this range, when you first start to see it here, we're already within the range where that light is having a strong effect on my finger. Now, when you put your finger up to a light, it's weird. It's like there's no heat, but you can feel it long before it gets there at times. And it's like an energetic charge. We know that light does a lot of things. We know that it travels as a particle and a wave, but I will add to that that it travels at a beam as well. That at all times, the difference between it being just a wave and we're not talking a wave like this, as I've shown, we're talking a vertical wave, and it travels as individual particles, and it travels as a beam. And individual beams are traveling because the light naturally, like we're seeing right here, spreads out. Right up against the sun, like we pretty much are, the light is a lot more even. But the farther out you get, the less even I suggest to you that that light will be. And as it spreads out, there will be pockets of density, just like we're seeing here. You see distinct bands, a really bright spot at the top that is clearly the brightest part of the light right here. And I have just blocked it out, but right there is that band at the top. And then underneath that, progressively lighter bands. But even at the bottom, you see another distinct bright spot at the bottom, and then another one in the middle. And in the middle of all that, you see one steady beam of equal particles. I predict that that is how light travels all the time. I have done a lot of camera lighting over the years. I have studied light all my life. I'm right about this. It travels as a beam all the time. We don't have to fire a laser. So to get these beams, this isn't a laser. This is just a light bulb. And it's not even a bright light bulb. And it was on one of three. Its weakest setting. Light is light. And I can turn this light up now that it's on this angle. And what did you just see? The charged particles in the room increased. The light across the room is increased. But so is the light from these bands. But at no time did the light change because this object's angle to the sun hasn't changed. And as it does, you don't see that change. You see it only proven out and shown out more and more and more as we turn across. And now we look at the sun, and what do we see? Beams of radiated light coming out, as well as particles coming out in waves. and forming like a particulate matter in front of me that you can see in this format. So, ladies and gentlemen, my theory on light suggests to you that it is traveling not only as an electromagnetically charged particle, as an electrically charged particle, but as a wave, as a beam, and as individual particles that are flooding a room all at the same time. Light is truly magical stuff. It is incredible stuff. And as I've shown here, regardless of the angle I choose towards this target, it is the same. Light is the same. Now, that is white light. Now, let me show the exact same experiment flipped around with yellow light. And at no point do we see this. Now, the sun produces this yellow light, guys. It is a very different kind of light. And as you can see by the difference, on the white side, we have these bands. On the yellow side, we do not. They never appear. Yellow light is a very evenly distributed light. It's a very different light than any other color of light. I have experimented with many colors of light, and in this video, I wanted to talk to you about my theory of light and the sun. Now, the sun is emitting multiple kinds of light. That's kind of the magic of it. It's not emitting one kind of light. So we can't account for only one band of light, because you can see here the distinct differences between white and yellow light, and why that might matter when we're trying to calculate mathematically how this object is speeding up. Because on the right, we can clearly see this white light is hitting these in very distinct beams. But at the same time, the yellow light is hitting very evenly. Well, the sun is doing both. That's my theory. And because it is, we will see pockets of outgassing happen in very precision marked spots where those beams are hitting it and charging it with radiation or electromagnetism or whatever it is, but it's not going to be electromagnetism that these particles inside of it are reacting to. It's going to be some form of heat, and that form is going to come in radiation at that distance. That can be carried on light. Light travels as radiation. Radiation travels as a wave in a particle, just like light does. Light and radiation are the same thing. You cannot have one without some level of the other, until we're talking artificial light. Now, there are so many different kinds of light, guys. Light is fascinating stuff. And I don't want to spend an hour getting into all the details of light here, but I do want to cover some of the differences, and I think I've done a really good job of showing you the differences in light and why it matters and what we're talking about here. Light is hitting it all at once and bathing it, but some parts of it remain in shadow, which will be the backside of it always, which is why the backside has a coma. Sir, dust is coming off and it's coming around. That might be dust. That might be a lot of things. We really don't know. In each case, it's different composition, which means it's different every time, because what's different in the core of a planet is different every time. What part of it broke up, whether it was a planet, or there's so many variations out there of bodies that can break up and end up being chunks of something that go by us. We have no idea what that object's history was. That's the trick. Without knowing its internal chemistry and knowing the sun's specific qualities, we can't really predict how those things will interact. The key, therefore, is light and charged particles to understanding these things, along with material sciences, chemistry, all of it, gravity, electromagnetism. All these things matter hugely, guys. So do the spin of the objects involved. The faster an object goes by, look at it this way. A train goes by you slowly, and there's a little rush of wind. You get closer and it's suction. That's a fact, because it has a rough surface. Well, so do planets. There's no smooth, perfect planets. And so, as they rotate, the faster they rotate, the more of a suction zone they create. The rougher the surface is, the more of a suction zone they create. Well, I believe that's what we're seeing when we think about gravity, is the rotation of the planet and the effect that has. Because you take that same train and you drive it by you fast enough, and all of a sudden the wind is enough to blow you back, and the suction is enough to suck you into the wheels. That is a fact. Lots of people have died from it. Look it up. And then imagine that on a planetary scale, on a body that's moving thousands of miles per hour in terms of its rotational speed. And now you understand we're going to have spatial level suction that could alter the travel of a planet. Absolutely. Without needing electromagnetism, without needing this so-called divoting of space-time. Just that simple math, just that simple known thing that we can quantify and calculate. The same is true with light. All these things are vital, guys. We have to incorporate them all into our model, or it will never be correct. And we will always be surprised by these objects until we have the ability to deep scan them and detect their chemistry from way out and understand all the mechanics well enough to know how it's going to interact as it enters our solar system. Until we have all those things dialed in to perfection mathematically, which we do not yet, it'll be this way. And so, I'd like you to take a look one last time at my beam experiment that demonstrates the third quality of light, that it does at all times travel as a beam when coming from our sun. There are individual laser beams of light within a band of light that is traveling as a wave and a particle set. And so we need to start looking at it that way, because in some of my experiments, it's very difficult for you to see the beam. But that's not a very hard thing to show out on camera. In fact, it's something you learn to avoid when you set up lighting. Well, I've learned that these things show different facets of light. It's what we're experimenting with when we're talking about camera work. It's all light. It's all photonics. And one of the reasons why I've always been able to provide good lighting on my videos when I want to is because I studied photonics. And I've got my eyes really well lit up right now because the exact light that I'm using complements them in a way that I don't do in other videos. I could do that every time to make myself look pretty, but it also complements the color on my skin. Weird, eh? Almost like I was born to be under a yellow sun. Kind of neat. We all are, eh? Again, it shows the way that light reflects. What if reflects and refracts? What if I am genetically engineered for a yellow sun? What if we all are? And that's why that particular light is more favorable to our eye. It looks better. It's softer. It feels better. But from the sun, we know that we are getting pretty much every kind of light that you could get. Huge amounts of radiation of varying types. There's a lot of things going on with the sun. And we really need to understand the types of light that are coming from the sun. And that alone, along with that light's individual charge, will tell us everything we need to know. Not so much, but it will give us a lot of clues as to how the sun really works and what we're seeing and how it's affecting other objects that the light is interacting with. We need to know how those beams affect it and what the charge is. Maybe these beams are separated by electrical charge. You ever thought of that? The sun is both positive and negative. It's spitting out both positive and negative. That's my guess. I think we need to expand our view of what light is capable of and what it is doing to objects that are going through our solar system. I also think we need to expand our view of gravity and realize that a spinning body in space is going to exhibit a huge suction, but also a repulsion, just like we see, just like the train, where at first there's a wind coming against you. Well, that makes sense because whenever any of these objects approach a body like Mars, they start spitting off dust and stuff. Well, that makes sense because they're in that zone where air is being pushed out, where molecules are being disturbed heavily by the rotation of the planet. Not by a dimpling space-time, by the simple fact that it has a very rough surface and it's spinning real fast.